Okay, addition. They're giving us some functions up here. The f of x equals 2x. And the g of x equals x plus 1. Quiet down. So they're saying, well, we're going to make a new function. Stop it. Stop. The h of x. Quiet. Gentlemen, quiet. We're going to create a new function called the h of x, and we're going to create that by taking the f of x function and adding to it the g of x function. So what is the f of x function? 2x. And what is the g of x function? So what's my h of x function? 3x plus 1. Okay. Are there any domain restrictions? Can x equal any number? Are there any domain restrictions? Can x equal anything? Yes. The only time you're going to get a domain restriction is in division where the g of x can't equal 0. Okay? Our domain is all reals, negative infinity to positive infinity. Okay? Subtraction. Now, subtraction, you have to be a little careful. Okay? My f of x is 2x. Guys, you're being way too... I have 2x minus my g of x is x plus 1. Now, this is where a lot of students make mistakes, because in subtraction, we have to use parentheses. Okay? Now we have to simplify. We have to distribute the minus sign. So I have 2x minus x minus 1. So I have x minus 1 as my new h of x. Okay? And again, my domain, I don't have any restrictions. Negative infinity, positive infinity, all real numbers are going to work. It's a line. Okay, next operation, multiplication. My f of x is 2x. This time I'm going to multiply it by the g of x, which is x plus 1. I have to distribute the 2x. What do I get? No, I'm multiplying. 2x squared plus 2x. Any domain restrictions here? No. All reals. Okay, division. The f of x is 2x. The g of x is x plus 1. Can I simplify this? No, I cannot. Okay? That's it. It's simplified. Do I have any domain restrictions? What is it? What can't be 0? Bottom one, right? We cannot have 0 in the bottom of a fraction, right? So x plus 1 cannot equal 0. So what can x not equal? Negative 1. There's my domain. All numbers except negative 1. Because you can't have a 0 in a fraction. But I mean, this could be negative or positive number. It doesn't matter. This can be negative or positive. Doesn't matter. This can be negative or positive or zero. It doesn't matter. But this cannot be zero in the denominator. It's illegal. Basically, at this level of your mathematics, yes. Okay. All right, let's look at some more examples here. What? Okay, in any fraction, you can do this, right? 0 divided by 3 is 0, right? Can you do this? No. So this, you cannot have 2x over 0. Okay? To make this x plus 1 equals 0, x could be negative 1. If x was negative 1, you would have 0 in the bottom. Any other number will work except negative 1, because negative 1 will give you 0 in the denominator. And you can't have that.
Is there any mathematical pi by 0?
No. I'm trying to think. I don't think so. That's a good research question. That's a good doctoral research paper question. No, I just x plus 1 cannot equal 0. Guys, quiet, I can't hear the question. What? Oh, up here? Yeah, because I had to distribute the negative. Okay. All right, let's keep going. What?
Is it 0 divided by 0?
Yes.
You technically divide by 0.
Again, I can't remember back from my theoretical mathematics days, okay? Let's go. Let's see, we have some new ones. The f of x is 2x cubed. The g of x is negative 6x squared. Let's do one set of these and add them together. The f of x is 2x cubed plus the g of x is negative 6x squared. Can I combine these? Nope. So I'm done. 2x cubed minus 6x squared. Okay, B. I have the f of x, which is 2x cubed minus parentheses the g of x, which is negative 6x squared. Simplify this. I get 2x cubed plus 6x squared. G of x. G of x is negative 6x squared plus the f of x, which is 2x cubed. It's the same thing as up there, right? 2x cubed minus 6x squared if we put it in standard form. And the g of x, which is negative 6x squared minus parentheses the f of x, which is 2x cubed. And we need to put this in standard form, so my negative 2x cubed goes first. And then I have a minus 6x squared. Yep. Let's do number 4. So we're going to go to multiplication now. Okay. Yes. Do we what? Okay, multiplication. The f of x is 2x times the g of x, which is x plus 3. So I have to distribute 2x times x. Is there a negative? Oh, that is a negative, isn't it? There is a negative there. So I have negative 2x squared minus 6x. And my domain can be anything, right? Yeah. All right, let's go back and do number 3. The f of x is 3x. I'm going to multiply it through the g of x, which is x to the 1/4. And when I multiply, don't forget there's a 1 there, right? When I multiply with the same base, I do what to the exponents? Add them. So 1 is 4/4 plus 1/4 is 5/4, right? Okay. I'm adding exponents. 1 plus 1/4 is 5/4. I'm sorry, what? Domain. Do I have any restrictions here? Nope. If my x was in the no, we still wouldn't have any restrictions. Okay, division. My f of x was what? 3x. And my g of x? Can I reduce this? I think I can. X to the first, right? If I'm dividing with the same base, what do I do with the exponents? Subtract them, right? So I have x to the 1 minus 1/4, which equals x to the 3/4. So I have 3 times x to the 3/4. And I don't think I have any restrictions, right? Nope. Well, even 0 to the 3/4 is 1, so 3 times 1 is 3. So we're good.
Wait, how is 0?
Well, sometimes fractions, again, you just, if you have a fraction, the denominator can't equal 0. After we simplified this, we don't have a fraction anymore. Okay?
How does 0?
Yes.
Wait.
Yeah. If x was 0, what's up? I have no idea. I think it has camera. Have a camera. All right. All right. A question. Our domain was all real numbers. Martin said, well, what if x was 0? Well, let's substitute in 0 for x. 0 raised to the 3/4 is what? 0 raised to any power is going to be 0. 0 times 3 is 0. So that's a valid answer. So 0 works. All right, let's do the other one, because this one's going to be a little bit more trickier. The f of x is what? Negative 2x. The g of x is x plus 3. Now, can we reduce this?
No.
No. So that's my answer. Negative 2x over x plus 3. Now, I ended up with a fraction after simplification, right? So now I'm going to have a domain restriction because I have a denominator other than 1. What would make my denominator 0? Negative 3. So x cannot equal negative 3. Okay. Because x plus, if I put, again, it's a fraction. So I cannot have 0 in the denominator. So the value of x, if I solve for x, subtract 3 from both sides, I get x equals negative 3. So negative 3 would make it 0. That's what, negative 3 would make that 0, so I can't let x be negative 3. Just the denominator. Equal it to 0 to find out what x cannot be. Okay. Yes, to find out what it can't be. Yes. Very good. Yes. Okay. I had to simplify this. Remember when we were doing exponent properties? When I have division with the same base, I subtract my exponents. So I took 1, x to the first, minus 1/4. That gives me x to the 3/4. Okay, that's what the property says. Okay, now, here's the hard part. Composite functions. Okay, composite functions. What time we get out of here?
11.
All right, it says practice with function operations 2015. You should be able to do page 1. Yeah, it's only 10 problems. Hang on. So on your practice packet, power functions, you should be able to do page 1 of the practice worksheets. So, hey, listen, on your first homework problem, where it says f of 2, what do you do with that 2? You just plug it in for n, right? So you have 2 plus 2, that's your f of n. plus your g of 2 is going to be 3 times 2 minus 5. Right? So that's your f of n, and that's, your f of 2 and your g of 2. And then you just sum. We did that yesterday. So I have 4 plus 1, which is 5. Okay? Now, if they don't have a number, you just leave them as the variables. So here I have the g of n, which is negative n squared minus 3, that's my g of n, plus my h of n, which is 3n plus 5. So you don't have to evaluate it because there's no numbers. So this equals negative n squared plus 3n plus 2. Okay? If there's a number, you have to evaluate it. If there's no number, just leave them as variables.